This is 3.4 logarithmic derivatives. So in this section, we're just learning one new rule, that the derivative with respect to x of the natural log of x is 1 over x. We're going to also learn a variation on this rule for when the base is something other than a natural log, the base of e. But the derivative of natural log of x is just 1 over x. So if you are taking the natural log of anything other than x, you also include the chain rule. So for this first example that says find the derivative with respect to x of the natural log of 5x, in the parentheses we have more than just x. So we're going to do chain rule. We'll say outer, derivative of the outer, inner, derivative of the inner. The outer is going to be natural log of something, so we'll put our parentheses. The inner is 5x. So to find the derivative of the outer, we're going to apply the derivative rule that's at the top of the page. We're just going to replace the x's with parentheses. So we're going to say 1 over parentheses for our derivative. And then derivative of the inner is just using constant multiple rule, so that's going to be 5. So to put this all together, it says what is the derivative? So we're going to say the derivative is, we're going to do 1 over the parentheses, and in the parentheses is going to go the 5x times the derivative of the inner. If we want to clean this up, we can put the 5 up top and make this 5 over 5x, and then cancel the 5's to make our answer 1 over x. For the next example, again, I'm going to use chain rule because I'm taking the natural log of something that's more than just x. It's not x, it's x squared. So I'm going to say outer, derivative of the outer, inner, derivative of the inner. The outer is going to include that 2, because that 2 is part of what could be the product rule, but we're not going to use the product rule. We're just going to go ahead and let the 2 hang along for the ride. And then the inner is x squared. The derivative of the outer is going to be 2 times 1 over the parentheses. And the derivative of the inner is 2x. So then we're going to say y prime equals 2 times 1 over the inner, which is x squared, times the derivative of the inner, which is 2x. And I can actually put this together because it's all multiplication. The 2x and the 2 can get multiplied together and put in the top. So we can say 4x over x squared. And I can actually simplify the x's because everything's multiplication. And I can just make this 4 over x. For the next example, I have to be very careful because I've got an exponent on a set of parentheses. So I have to be aware of what's getting raised to the third power. It's not the natural log that's getting raised to the third power. It's what's inside the natural log that's getting raised to the third power. So when I write down my outer, it's going to be natural log of something. And then the inner is going to be everything else, the 2x plus 1 to the third power. So when I do the derivative of the outer, I'm just using the rule from the top of the page that says 1 over parentheses. When I do the derivative of the inner, however, I've got something cubed. Well, that something is more than just x. And so if it's more than just x, it requires chain rule. So to do derivative of the inner, I'm going to do another set of outer, which is something to the third power, derivative of the outer, which is 3 something squared, inner, which is going to be 2x plus 1, and derivative of the inner, which is just going to be 2. So putting that all together, in my derivative of the inner for the original problem, I'm going to have 3 parentheses squared. In the parentheses goes the 2x plus 1, and then multiply by the 2. So now I can do the original chain rule. I can say dy dx, because the problem tells me to call my derivative dy dx, equals, and I can do 1 over the original inner, so we can say 2x plus 1 cubed times the derivative of the inner, which is going to be 3 parenthesis 2x plus 1 cubed, squared, times 2. And just to clean this up a little bit, I can take the 3 and the 2 that I have here, and I can multiply them together and put that in the top. So I can make this 6 times 2x plus 1 squared over 2x plus 1 cubed. And because the 2x plus 1 squared and cubed are getting multiplied, I can cancel out some of those. I've got 3 in the bottom and 2 in the top. So I can cancel out 2 of them in the top and 2 of them in the bottom, leaving me with 6 over 2x plus 1. For the next example, this one is different from the one that we just did because the natural log is inside the parentheses. So the squared applies to the natural log, whereas the example we just did, the cube did not apply to the natural log. So our outer this time is just going to be parentheses squared, which means derivative of the outer is 2 times parentheses. The inner is going to be natural log of x, and the derivative of the inner is 1 over x. And so then f prime of x is going to be 2 times the parentheses. In the parentheses, we put natural log of x, and then times the derivative of the inner, which is 1 over x. And we can write this like that, or we can write it as 2 natural log of x over x. On the next page, we're going to be dealing with, instead of natural log, logs with base other than e. So the natural log is a base of e. Any other log base is going to be log base a. And you may see it with a base. You may see log base 3, log base 2, log base whatever. You may see y equals just log of x. And if you see that, it's really base 10. So the only difference between the log rule that we just talked about with natural log and this log rule is we add just a little bit to the denominator. You can still see that we have the 1 over x that we had in the original rule. I just highlighted it there in blue. But we also add on natural log of the base in the denominator. Okay, and this is to correct for the log not being a natural log, because most of the time in mathematics we deal with natural log. So for the first example, if we want to find the derivative of 2 log of x base 3, the x is all by itself, first of all. Notice that there is nothing going on with the x. It's not squared, it's not cubed, there's no number in front of it. The little 3 belongs to the log. That identifies the log as a log base 3, so it's not part of the argument. So because it's that all by itself, we can just directly apply the rule. So we can say g prime of x. The 2 is going to come along for the ride, as most of these little coefficients are going to do. And then we're going to apply the rule. And the rule says 1 over x natural log of the base. And we can clean this up a little bit if we want to. We can put the 2 in the top and say 2 over x natural log of 3. Okay. So that's what the problem looks like without the chain rule. With the chain rule, we're going to have something that's inside the parentheses that follow the log other than just an x. So you can see in this one to the right here, we've got x cubed minus 2x plus 1. So we're going to say outer, derivative of the outer, inner, derivative of the inner. The outer is our log, so log base 7 of something. The inner is the polynomial, x cubed minus 2x plus 1. The derivative of the outer is going to be using our rule, so 1 over parentheses natural log of 7, because the base was 7. And the derivative of the inner is going to be 3x squared minus 2. So then we put it all together. We can say y prime equals 1 over, in the parentheses goes the inner, so I'm going to put in x cubed minus 2x plus 1, and then follow that with the natural log of 7, and then multiply it by the derivative of the inner, and I'm going to put that in parentheses because it has multiple terms, so the 3x squared minus 2. If we want to clean this up, we can put the 3x squared minus 2 in the top, and then the rest of it stays the same in the bottom. Plus 1, natural log of 7. Next example, very similar. This time we have a log without a number written. So that without a number written is a base 10. So I'll write myself a little note. This guy is base 10. The x is not by itself. It has a 4 in front of it, so this is a chain rule problem. So we'll say outer, derivative of the outer, inner, derivative of the inner. Outer is going to be 1/2 log of something. So the derivative of the outer is going to include the 1/2, but it's also going to have 1 over something natural log of 10, because again, base is 10. The inner is 4x, and the derivative of the inner is 4. So we put it all together. We're going to say h prime of x equals 1/2. And then we're going to do 1 over the inner, so 4x natural log of 10, times the derivative of the inner. And if we want to clean this up, we can go ahead and say 4 in the top over 2 times 4x natural log of 10. The 4's will cancel. And so we're left with 1 over 2x natural log of 10. Save the best for last. This one, when you look at it, I see 2 x's multiplied together. It's x times the log of x squared. So we're going to have to do product rule with this one. So I'm going to go ahead and set up my box, put my x and my log of x squared base 2. The derivative of x is 1. The log, if you look at the x, has more than just x. It's x squared, so it's going to need chain rule. So I will, in a different color, say outer is log base 2 of something. The derivative of the outer is going to be 1 over something natural log of 2. The inner is going to be x squared. And the derivative of the inner is going to be 2x. Putting that all together, I'm going to write it down here because it's going to get a little big. We're going to have 1 over x squared natural log of 2 times derivative of the inner, 2x. Putting this all together, we can say y prime equals, we'll do the diagonal lower left to upper right, so that's going to be 1 times log of x squared base 2 plus then we're going to say x times the derivative that we just got. So the chain rule that we just did. And so that chain rule that we just did is 2x over x squared natural log of 2. I just kind of merged it together there. And we can clean this up a little bit, not so much with the log of x squared base 2, but with the fraction, because that's going to end up being 2x squared over x squared natural log of 2, which we can write as log of x squared base 2 plus the x squareds will cancel, so we'll just have 2 over natural log of 2.